All right, welcome to the Outdoor Center here in North Idaho College. My name's Terry Brinton, and I'm the assistant coordinator for the program here. One of the many things that we do is we offer bike maintenance clinics for students in the community, and we're glad to invite you into the shop to cover some of ABCs of bike maintenance today. So in front of me I've got two bikes up on our stands. We've got a sort of hybrid bike here, a combination mountain and road bike that's just generally designed for riding on the road and riding on trails. Over here we've got a mountain bike. The bike that you have might be different than these, but a lot of the same concepts will apply. And we'll talk about that as we go along. So when we say ABCs of bike maintenance, what we're talking about is a basic safety check to go through the primary systems of your bike. And this is something that you should do probably at least once a year, depending on how much you ride. But at least when the bike comes out of the garage in the beginning of the spring, if it's been in there all winter, it's probably a good idea to go through each one of these systems and make sure it's safe for the road or trail. So ABCs, we'll start with A, and A is for air, so that's going to stand for any of the issues that you might have with tires or with wheels. So a quick little pinch on the sidewalls of your tires are going to tell you if you've got a problem or not. It's not uncommon to expect one or both tires to be flat if it's been sitting for the entire winter. The air molecules actually leak out between the rubber molecules slowly over time, and that process goes faster if it's a higher pressure tire, slower if it's a lower pressure tire. And we'll talk about tire pressures in just a minute. But if you get a quick little squeeze and see if there's any issues with that tire, if it's soft but there's still some pressure in there, there's likely no issue with the tire or tube or rim or system. All it needs is just a little bit more air pressure added. If it's dead flat, like this one here, we probably want to do a little bit of investigation just to make sure that there's not a problem with your, you don't have something going on with your tube inside the tire, or if it's a tubeless system, you don't have a problem with that. So what we're going to do here is we're going to first remove the wheel. Now, when we remove a wheel, we're going to need to do two things. We're going to need to make sure that we've got our chain shifted down into the smallest diameter cog on your chain, on your cog set. If you have gears on your bike, if you don't have gears, you don't have to worry about that. Shifting down onto the smallest cog is going to make it easier to remove the wheel from the rim. It's kind of becomes a tangled mess when you release the axle if you've got it up in the high gear here. So what we're going to do as well is we're going to release the brakes. Every braking system is going to have some way of relieving the brake, the tension on the cable, so the brakes open up and the tire can come out. With skinny tires like this, it's a little bit easier to get the tire through, but if you've got big fat tires on your mountain bike and it's got rim brakes on it, you're definitely going to need to be able to release those brakes to fit that tire out through. And so for V-brakes, which is what these are, we're going to reach up here to this little silver piece, which is called the noodle, and we're going to pinch with one hand and we're going to unhook the noodle from its bracket on the one brake arm. And when we do that, we can see the brake arms come out, opens up the pads, and the tire can now come out. So next thing we're going to do is make sure we're shifted all the way down. I have the bikes on a bike stand here. If you don't have a bike stand, that's fine. You can turn the bike upside down on the ground. It's difficult to do anything with the drivetrain when the bike is upside down, but it's certainly easy to remove the wheel. You're just going to have to either lift up the seat, shift it down into the highest gear, and crank the pedals a little bit so the chain moves down, and then you'll be ready. I'd also like to not recommend grabbing onto a spinning wheel if you do have it on a stand. There's a lot of inertia in this, and your hand's going to go a little bit it's going to bring your hand down into something complicated a little bit harder than you might think. So I'll wait for that to slow down. Go ahead and grab it at that point. And now we're just going to release the quick release on the non-drive side. That's just the lever right there. And as the wheel drops down, what I'm going to do is I'm going to pull back on the derailleur like this. And notice that opens up the space so that the wheel can drop down and around. And then it'll come right out. All right. So now I'm just going to have a seat right here. Now, taking a tire off the rim can be a little bit tricky sometimes. There's a couple of hints that we can give you that make it a lot easier. First thing you want to do is make sure that the tire is completely flat. And right now, as you see, as I drop it down on the ground, there's still a little bit of air pressure holding it up. So I'm going to grab a small screwdriver. And this has a Schrader valve. There's two different types of valves on bike tires. What we've got behind me here is a Presta valve. You may not be able to see it, but the difference is this one's a little skinnier, and it has a little nut that needs to be gently unscrewed a short ways before you can let pressure out. Once that nut is unscrewed on a Presta valve, you can just push the little push the nut and the little bolt that comes out of it right here, and the air will come out. But for a Schrader valve, which is like what you have on your car, you do need something to depress the pin on the inside of the valve. And so I'm just going to gently reach up, and you can hear that last bit of pressure come out. I'm also pushing down, so I'm flattening out the tube a little bit on the bottom. And once that's loose, I'm then going to grab my tire lever. You may be able to take the tire right off the rim with your bare hands without having to use a tire lever, which is the tool I have right here. But in either case, what you want to first do is identify where you're going to first remove the tire from the rim. We don't want to do that right on the valve or right opposite the valve, so I want to have the valve off to one side. And what I'm going to do is I'm going to be pinching in on the opposite side of where I'm going to break the tire off the rim. And what I'm doing is I'm trying to make sure that the tire can pinch together and come up into the channel in the center of the rim, just right up in here. And when that occurs, it gives me a little extra slack on the opposite side. Now, it's almost like the whole wheel shifts down inside the tire a little bit. And then I'm going to see if I can just roll. Nope, that's a little bit difficult to just roll that over with my bare hand, so I'm going to use my tire lever. There's a couple of different styles of these out there. I do recommend using a plastic one if you can. It's less likely to damage the tube if it's not already damaged inside. I'm going to hook that right under one bead of the tire, so just one side. And when I say bead, I refer to the little edge of the tire right here. And I'm being very careful to grab the tire only, not the tube behind it. If you grab both of those, there's a chance that you might put a hole in the tube that wasn't there before, and then you may not find the original hole that is the reason this tire went flat to begin with. So once I get to this point, rather than try to push the tire lever all in one direction, I'm going to hold it like this. I'm going to watch my knuckles on the spokes, and I'm just going to gently move it back and forth just a little bit, opening it a little further with each go until I get to that point. And then I'm just going to make sure that it comes all the way off. And when I'm rubbing my fingers up around the inside of the tire, I'm just going inside the bead. I'm not rubbing them all the way up on the inside of the top of the tire, in case there's a nail or a piece of glass or something that went through this tire and it's sticking through. And if I was sliding my fingers along the inside, it might cut you. So make sure that's out all the way around. I'm going to come to the valve like so. And I'm just going to pull that valve up through the rim and out the other side. And we can now just remove this whole deal from the tire. So anytime you have a flat tire, you want to figure out why the tire went flat. There's a couple of different ways that can happen. You can get a puncture, which is very simple. It's just some sharp object went right through the top of the tire, through the tire and into the tube. And oftentimes those can give you really small little pinholes that'll give you a slow leak. It can be a little hard to track down. You also might get a pinch flat, and that's where your pressure might be a little too low and you hit a sharp object or a curb or some kind of square edge, and the tire becomes pinched like that between the rim and the object that you hit, in which case the right at the site of that pinch, there's going to be two little holes that are created in the tube itself, and it looks like a little snake bite, and it'll be on the side of the tire. And so that's a telltale sign that it was a pinch flat. Usually if it's a pinch flat, there's no other issue that you have to sort out. You just have to either patch the tube or replace it and pump the tire back up to its recommended pressure, and you shouldn't have that issue. And then finally, you could have a problem with the rim strip itself. And if I peel the tire back and show like that, you can see there's this yellow tape on the inside. That tape goes over the spoke holes in the rim, which can sometimes be a little sharp. If that has been damaged or shifted to one side, what can happen is when you pump up the tube kind of pushes down into those little holes, and then it will eventually, that sharp edge of the hole will cut into the tube inside the tire. And those can be kind of the most mysterious flats sometimes if you don't know what to look for. And had lots of reports of people who thought they had a puncture or a pinch flat. They just changed the tube, didn't address the rim strip, put the new tube in there, pump it up, go riding. They might get a few miles from the house, and then it goes flat again. So you want to make sure to inspect that rim strip if you suspect that's the issue. One telltale sign that you have a problem with your rim strip is when you pull out the old tube, you will see on the inside, you'll see a cut, and it usually looks like a half moon kind of shape or a half of a circle. And that's that circle of the hole in the top of the rim that's cutting into there. In any case, we want to identify that problem so that we don't put a new tube in there and go through all the effort of changing it and then wind up with another flat just down the road. If you do have a puncture, we are going to want to identify where that puncture happened on the tire and make sure that that object is not still in there. Here in North Idaho, we don't have a lot of problems with thorns or goat heads or cacti or things that give punctures in other parts of the country. But everywhere where people ride on the road, we have the issue of little pieces of steel wire that come out of car tires, tend to get swept to the gutters on either side of the road, especially in the spring or after a rain. If you're riding down the edge of the road, you might pick one of those up in your tire and it'll slowly work its way in and give you a little bit of a puncture. So we can still get those here. So once we remove the tube from the tire, in order to just make sure that we know why that tire went flat, we're going to put a little bit of air pressure in it so we can identify where the air is coming out. I'm going to make sure I get the right side of my pump here because it has two different sides on the pump head for the different types of valves. Your pump may vary. And I'm just going to pump up just enough until the tube starts to swell a little bit, like so. I'm going to take that off. Now what I'm going to do is I'm going to visually inspect, and I'm going to listen for any air coming out. And sometimes it's a little hard to tell. If it's a very small hole or a very slow leak, you might have to do this. And what I'm doing here is I'm listening and I'm feeling with the skin on my cheek, which is very, very sensitive. If you have a little bit of air coming out, you'll feel it this way pretty well. Another thing that can happen with tubes is you can have some damage to the valve itself. And if you're trying to identify that, a good way to do that is to put a little bit of either soapy water or even a little bit of spit on the end of the valve, and it'll start to bubble if air is leaking out. We'll talk about this when we reinstall the tube, but if the valve stem here is allowed to be crooked in the hole in the rim can cut into the side of the valve stem, and so you'll want to just inspect that and make sure that that's okay. That's not a repairable thing. You'd have to replace the tube if that was an issue. And then lastly, if you can't identify the hole with any one of these techniques, the surefire way is to fill a tub with some water or a bucket with some water. submerge the tube or part of the tube and slowly go around and just look for any bubbles that are coming out. A very small leak will be obvious in that situation. So if you can't identify a hole in there using any one of those techniques, it's likely that it just sat for a long time and maybe it didn't have a lot of pressure in it to begin with when you put it away in the fall, and that tube is fine. You can go ahead and reinstall it and pump it up to pressure and go ahead and ride. If there is an issue, like I said, you can patch it or you can replace it. I'm a big proponent of trying to get the most life out of these things, and so you can pick up tire patch kits from any bike shop, and they come with instructions. You can find them on the internet. So after your tube is repaired, we're going to, first we're going to let a little bit of air out. I want enough air in my tube that it holds its shape, but not enough that it's actually stretched at all. So I'm going to let air out until it sort of collapses a little bit where I'm holding it. There we go. Just enough air to hold its shape. And that's going to help make sure that we don't catch it with the tire lever and damage it when we're putting it back in. So now I'm going to make sure that I have one side, the side closest to me, of the tire in the rim all the way around. And then I've got the valve positioned right at the top of the rim here, or the valve hole. And I'm gonna go ahead and take my tube and I'm gonna insert the valve stem in there, and then I'm going to just now tuck that tube up into the rim. And this is where having that little bit of pressure, just enough to hold its shape, is going to be really helpful in letting the tube just sit nicely nested inside the tire like that. If it's totally flat, it's going to be kind of flopping around and it'll be getting stuck under the bead of the tire. And so, all right, and now I'm just going to roll, starting at the valve, roll the second bead of the tire into the rim. I'm going to work my way about a quarter of the way around on one side, and then I'm going to continue around the other side. Notice I'm holding this here so it doesn't peel back out. I'm going to work my way around till I get most of it in. It's going to start getting tight right about there. So now I've got it all in there except for this one little section right here. And then again, I'm going to work opposite where I'm trying to get the last bit of the tire in. I'm going to pinch the two side walls of the tire on this side, and those beads are going to drop into that groove that runs all the way around the inside of the rim. And that's going to give me a little bit more slack to operate up here, and notice I can just pop it back in with my hands. Especially when we're reinstalling a new tube or a clean tube inside here, if we can get away without using the tire levers, we really should, because there's a lot of potential for damaging your new tool when you're your new tube when you're putting the tire back on with the tire lever. If you do need to use the tire lever, it's just going to be a matter of getting it close. And then you're going to, with the hook facing in towards the rim, I'm going to just, well, that's, it's popping itself right on. But what I'm going to do is I'm just going to get it right in there under the bead. Hang on. There we go. I'm going to get it right in there under the bead, being very careful not to hook the tube and pinch it between the lever and the rim. I'm just on the rim only, and the best way to do that is to actually slide the tool up the rim and then in when I'm doing that. And then I'm just going to flip it up, and then I'm going to do the same down here all the way around until that tire goes in. And if it's really fighting you, check to make sure that you didn't have too much pressure in the tube, and that the opposite of where you're working, you're able to pinch the tire together and let it fall into that groove. The reason that we don't work right on top of the valve, with either the valve here or the valve here, is because where the valve goes into the tube, there's some reinforcement, and it makes it difficult for you to pinch that tire together and get it up inside that groove, giving yourself slack on the opposite side. And that's a little trick that, you know, not a lot of people know, but man, it'll make your life a lot easier. Okay, got our tire reinstalled. Next thing we're gonna do is we're gonna install our pump on the tire. With this one, and with what the setup that you're using, you might need to hold your thumb down like so that you're providing some support so that the valve doesn't just push right back up into the rim. So I'm gonna hold that down and get the pump on there, like so. And I'm just gonna give it about 5 to 10 PSI to start with. And I've got a gauge on my pump here that's gonna tell me what's happening. Just enough so that the tube fills up the inside of the tire completely. And pop that off for just a second. And what I wanna do now is I wanna kind of rock the tire gently, like this, with my hands. You want it soft enough that you can easily manipulate it a little bit, but firm enough that that tube is fully inflated and filled the void inside the tire. And what we're doing is making sure that the tire is centered all the way around on the rim, and that we don't have one spot where the bead is up in that groove and another spot opposite where the bead is trying to pop off. We do want that when we're removing it. We don't want that when we're reinstalling it. And if we look carefully, we can see these tires all have like sort of a line cast into the rubber that goes just outside the rim. And I can just visually inspect, see right here, I see that line right there. It kind of disappears for a second, and then it comes back out again right there. So I know that this is a spot where that bead needs to come up so that it sits in the right spot on the inside of the rim. And if I just rock that gently, like so, now it's showing all the way around. And I know that tire is nice and centered on the wheel. The other thing that you can do is you can give the wheel a quick little spin, like this. If there's a problem and I'm seeing one spot where there's a little bit of a lump, I'll wait for that to come around. There it is. And then if I visually inspect, I can see that line cast in the tires disappearing again, popping out again right there. Just gonna give it a little rock, like so, and it'll pop right out. There it goes. Perfect. All right, once that's all in there and you're pretty certain that the tire's centered, we're gonna reinstall the pump. When you're doing this, especially if it's a Presta valve, like on this bike or what you'll find on road bikes with skinny tires, you want to be really careful that the pump head goes straight onto the valve and comes straight off of it, that you're not torquing it like this. Those valves with the little brass bolt that comes out right there, that's a very fine thread, very narrow diameter brass bolt, and brass is pretty soft. So it's quite easy to either bend or break that thing, in which case you'll have to either replace the valve core or get a new tube, depending on how it's set up. So in order to get this straight on there, I like this method where I'm putting my thumb on the top of the tire and then pushing up with my fingers from underneath, like so. And then I'm just going to give her about, with this tire, I believe we can look and see what the recommended inflation is going to be. We've got, it says minimum 50, maximum 85. So we never have to go to or we often don't have to go to the maximum tire pressure with our tires. In fact, most tires will be efficient and comfortable at about 10% below their maximum inflation. And that's going to vary a little bit depending on the geometry of your bike, whether it weights the front wheel or the back wheel equally, or if there's, if you're on a bike like this where you sit upright and you're sitting on the seat with most of your weight, the back tire is going to need a little more pressure than the front. If you're on a road bike that has the drop handlebars on it and your pressure is kind of equalized between your hands and the pedals in the seat, then you can have even pressure in both wheels. the idea is that if there's more weight on that wheel, it needs a little more pressure. So if this one said 50 to 85, I'm probably going to go up to about 65 with it. That'll give me the right kind of balance of compliance and pedaling efficiency. So when we think about pressures for tires, the skinnier the tire, the higher the pressure it's going to need. So if we're on a road bike that you might ride a race on, it may be as much as 150 psi if they're those little skinny tires. If I'm on a hybrid bike like this, it might be 60 to 80. If I'm on a standard mountain bike with like a 2.3 inch tire, that'll be written on the tire itself, that one's going to be about 35 psi. If I'm on a fat tired mountain bike like this, it might be as low as 15, or the big fat tires that you see people ride on snow and on sand, those ones might be in single digits. It might only be 8 or 9 psi in those tires. So you want to familiarize yourself with the pressures that you need, because if we run too low, as we know, we'll get flats. If it's too high, you could, well, it's going to be a harsh ride for one, and you're not going to have a lot of traction, so it's not as safe. So you want the right pressure. Now we're going to reinstall the wheel on the tire, or on the bike. Come along to here. All of these things are so much easier if you do have a bike stand. But again, this is something, if I didn't have a bike stand, I would turn the bike upside down and being careful not to damage the seat or the handlebars, and then work in that way. So what I need to do here is I need to take the bottom part of the chain and make sure that clears around, and then I'm going to try and take the top part of the chain and land on the gear that I have it shifted into. And if we'll recall, I have it down on the smallest cog. So I'm going to make sure that lines right up with that smallest cog. And I'm going to rotate the derailleur back just a little bit like this, making sure that the pulley can clear around the second here. Making sure that the pulley on the derailleur can clear around the oops, hang on a second. Make sure the chain is on the pulley on the derailleur. There we go. Okay. Yeah, it's worth taking time and making sure everything's lined up right before you try to jam it in there, because once, there we go. All right. Now we've got it all lined up, and I'm using my thumbs on the frame and my fingers on both sides to lift the wheel up into the bike, making sure it's nice and centered up into the dropouts, which are the part of the frame that accept the wheel. And I'm going to adjust the tension on the adjustable side of my quick release here, so that, and I'm just holding this side fixed while I turn this side with my thumbs. And I want to make sure that when I close the lever on this side of the bike, that the tension comes on at about half closed to about 2/3 closed. So right about there. I'm just going to give it just another quarter turn. I open it up, put a quarter turn. There we go. So if I feel it start to firm up when I'm about half to 2/3 closed, then I know that's right. And I'm going to close it so that I can get my fingers behind it when I need to get it open the next time. If I closed it hard against the frame, it's going to be hard to get your fingers under there to get it off the next time. So do that, and there we go. So that covers our tire and wheel issues. You may have a tubeless setup, so no inner tube, kind of like in your car. There might be some sealant in there. That's common on mountain bikes and becoming common on higher end road bikes. If that's the case, there's some separate issues that you might have to deal with seasonally, changing those fluids inside the tire. If you need help with that, I recommend going to a local bike shop and they can help you get set up. Tubeless setups are very low maintenance once they're set up properly. Very difficult to actually get a flat with a tubeless tire, but it is a little finicky to set up in some cases. So I recommend going to a bike mechanic for that. Okay. Lastly, we want to make sure that when we reinstall our wheel, that we also remember to hook up our brakes again. You don't want to hop on here and jump down to go rip down the hill in front of your house and remember that you forgot to hook up your brakes, because you will not have any braking power from this right now. So to do that, I'm going to pinch the two arms of the brakes together on one side, and then I'm going to reconnect the noodle. This one's a little tight, so I'm going to relieve some tension up here at the bar. Don't worry about this. We'll talk about that in a minute. I'm going to relieve some tension, and now I should be able to easily get that hooked up. Like so. All right. Now, your brakes may look different than this. They might be a caliper that goes around the rim like so. You'll find that on road bikes and on older mountain bikes and kids' bikes a lot. We'll have a caliper like that. Those calipers will often have a little lever on one side that you flip up and it opens up. They might have two little arms out like this with a cable that kind of bridges across either side, and then there's another little cable that goes up to your handlebars that hooks onto that and it pulls it this way. Those ones you'll just unhook the one cable that goes up to the bars, leaving the other cable on the sides, or maybe it unhooks on one side. The point is, every type of brake has some way of relieving that tension. So we just want to make sure we return it to the proper setting when we return the wheel. Okay, we're going to move on to the B of our ABCs today. That's our braking systems. There's a number of different style of brakes that you're going to find on different bikes out there. We can kind of break them down into two categories. One is going to be rim brakes, and the other is going to be disc brakes. So on this bike I have in front of me right here, we have rim brakes, meaning the brake system applies pressure to the rim of the wheel of the bike, and that's what slows you down. Over here behind me, I've got disc brakes on this bike. So there's a metal disc that's attached to the wheel that goes through this caliper like this, and inside of that caliper there's some pads that pinch this disc, and that's what slows you down. This is similar to what you find on a motorcycle or on a car. And so two different systems. We're going to focus mainly on the rim brakes, because that's most of the bikes out there have this. We're moving towards that with certain types of bikes. But the rim brakes, we're going to want to examine the system from one end to the other. So we've got levers on the bar that pull on a cable that the cable itself pushes against the housing. So we've got the housing, which is the black part of the outside of the cable, and then there's a steel cable that runs inside of that. When we pull the brake lever, what we're actually doing is we are pulling the cable against the housing. And so both of those components are critical to applying force to the brake caliper itself. So what we want to do is we want to first inspect for any damage of the system. So a couple of common places where we might find damage is right where the housing enters the lever or the caliper at either end. They can become kinked if we see any type of damage where the inside of the housing is exposed, or if the black part of the housing has crept back and now we see the metal reinforcement, or if there's any cracking, or if it's excessively dirty, we may want to replace the cable, and I would recommend taking the bike to a bike shop for that. The cable and housing are not very expensive, and if there's damage, it's going to really mess up your whole system, so it's worthwhile replacing every once in a while. The other thing is that this system requires that cable be running freely inside the housing, so with very little friction if possible. These modern style cables have a low friction sleeve on the inside of the housing that allows the cable to slide easily. But if the cable has become rusty, or if there is oil or dirt has gotten in there and gummed it up, then that cable won't be able to slide freely. And so when we depress the brake lever, we're pulling the cable through and we're compressing a spring of some type inside the caliper here, so that when we release the brake lever, that spring takes over and pulls the cable back in the other direction. If we have contamination inside the cable, then the spring is not going to be able to fully return the brake, and what'll happen is the brake will be rubbing on the rim a little bit, and our lever is going to be kind of floppy up here. That's the kind of telltale sign that you've got a damaged cable, is if your lever is kind of floppy. If that's functioning properly, then we're going to move on to the next part of the system. With these V-brakes, I'm going to examine very closely where the noodle, this silver part here, attaches to the caliper. And if you'll recall from our removing the wheel, that's there to help remove the tension from the system. I can unhook that like so and pop it back in. But what I want to make sure is that there is no damage to this bracket, this metal bracket right here that accepts the noodle. Because if there is damage right there, if it's bent open or something like that, if you pulled the brake really hard, it could pop out of there and then you lose your braking. So that usually happens at the worst possible time, when you're squeezing the brake really hard because you're really trying to stop and avoid something. So we want to make sure that that doesn't pop out of there. There's other systems, as I said before, that have different ways of relieving the tension. We just want to make sure that it's all functioning properly and that it looks right. If you see damage or you think you see damage, it's worthwhile just taking the bike by a bike shop. They'll very quickly be able to look at it and say, oh, that's fine, or oh no, I think it needs to be worked on. They usually don't charge for that kind of service. So, okay, moving on to the next part, we're going to want to make sure that when we pull the brake lever, that the arms of the brake caliper come in unison and they look symmetrical. And then we're going to look and make sure that the brake pad, which is the rubber part right here, is hitting the rim squarely. So what we don't want is if we imagine the pads coming in at the rim like this, if they're tipped in a weird angle, if they've become moved, sometimes these get bumped and they might get moved, or transport damage. A lot of different things that can happen that might make those move. But if one is down and you pull your brake in, that pad might hit the rim and pop down underneath it. Or if it's turned, the pad might contact the tire, and you really don't want that to happen. If your brake pad is touching your tire and you're out riding and you pull the brake, that brake pad will create a ton of friction against the rubber of the tire, and it will very quickly cut through the sidewall of the tire, causing a flat. And when that happens, the tube bubbles out and explodes. It sounds a bit like a gunshot, and it can scare you. So it can happen very quickly. So it's pretty easy to tell if that's happening. If you look at the tire, you'll see a groove worn in all the way around on the sidewall. So if you see that happening, you want to make sure that that's fixed immediately, like stop riding right away. To adjust that, on this brake, it's a Allen wrench on this little nut right here. And what I would do, I believe that's a 5mm. All of your bolts on nearly all bicycles these days are going to be in metric sizes. So you'll want to make sure you use the right tool. And this is a 5mm Allen wrench. And what I would do is I would pinch the two calipers together with my hands. And then with the other hand, I'm going to loosen that bolt like so. And if we notice just inside of there, we've got a spherical washer on both sides that allows that brake pad to be kind of moved around in 360 degrees. The idea is that we can position it so that the pad hits the rim very squarely and just in the right spot. Once we've got that positioned, I'm still pinching with this hand here, making sure it's holding that in place. And I'm going to just gently snug this up. And then to do the final tightening, I would I would open up the brake caliper again, like so, and I would hold the pad with one hand, and then I'm gonna make sure it does not move, and I'm gonna tighten the nut with the other. If we're not holding the pad firmly, we might turn it with that final tightening. So then I'm just going to then check again, making sure that's hitting the rim squarely, which it looks like it is. And I'm going to pop this back in. So I mentioned before that there's a number of ways that this can get bumped out of place. It's also going to need to be adjusted periodically, maybe once or twice, as those pads wear down. So again, as the pads wear, they're going to come further in. And because they operate on most brakes, they operate on kind of a gentle arc as they're swinging in around this pivot. If the pads wear and they come in further, they're going to start coming in and going down further. And so we would want to readjust them so that they hit the rim squarely and apply that force in a perpendicular fashion to the rim itself. As I mentioned before, these pads do wear over time, so you will want to visually inspect that you still have, if I open this up, I can see a groove cut across the pad. It's much like your tires on your car. If that groove disappears, then you've got bald tires. Same deal, if that groove disappears, that means that the brake pad material is pretty much worn away and these need to be replaced. Replacing them is just a matter of taking that off, that nut that we were adjusting before, taking that off, putting the new ones on, and doing that same adjustment again, and then you'll be moving down the road. The other thing that can happen to your brake pads is if they're really, really old, as we know, rubber will change its consistency over time. So these things create friction that slows you down by being soft rubber, and so over time they will harden, and that'll reduce their effectiveness. So they may look great, they may still have plenty of tread left on them, but if you can hear them kind of clack when they hit the rim, then they're probably really old and really hard, and they're not giving you the kind of friction that you need. Likely in that situation, they're also going to be squealing quite a lot. So if your brakes make a weird noise, usually it's because the pads are old or they've become contaminated with some sort of oil or something that's hardened the rubber and maybe left a deposit on the rim as well. So a couple of things you can do to try and get a little more life out of that pad if you want to is you can take a little sandpaper to the rim, and as you go around, you're just freshening up that surface, removing any contamination right there. You can wash the pad with soap and water and a nice soft brush, and that soapy water will get rid of any contamination on the pad. That might get you a little bit longer, but I'll tell you, nothing makes it perform better than a nice new set of pads, and they don't cost very much, so you want to be able to stop. Other noises that you might get if you're riding along and you hear the brake make a pulsing noise, so they'll go ka-ch, 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 or like a squeak. That usually means that there's a wobble in your rim. The rim might be a little bent. This system kind of is dependent on the rim being straight and true. And so if there's a periodic wobble, or if you look down and you see the brake arm as you're riding go doom, 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 like that, it's hitting a bump on the rim, and that rim probably needs to go into the bike shop to get a wheel truing service done. That's not something that I would recommend doing at home. It requires special tools and a special fixture to do it, and a little bit of know-how. So, so that covers most issues with rim brakes. They're a pretty simple system. Again, it's mainly inspecting for damage and replacing damaged components. The final thing that I want to address with these is any system that uses a cable to actuate it is going to have a fine adjustment on that cable that you can adjust without releasing the cable on the bolt down here. So if I want to add tension or relieve tension from the system, say the lever barely moves, and as soon as I pull it even a little bit, the pads are locking up, or if they're just rubbing in general when I'm riding along without applying any tension up here, then we may want to relieve some overall tension to the cable. Or if I can pull the brake all the way back to the bar and it's still not slowing me down, then I want to add some tension to the system. And the way that's done on this is right here at the lever. This is what we call our barrel adjuster. So what this does is it moves the stop where the cable housing is held in the lever in or out in relation to where the end of the inner cable is held. So if I'm holding the inner cable here with the lever and I'm holding the outer cable, the housing out here with the barrel adjuster, if I unscrew the barrel adjuster, I'm going to pull the housing out against the cable, adding tension. If I screw the barrel adjuster back into the lever, I'm going to be moving that stop in closer, relieving tension. So the way that works is if you unscrew the lock ring back, I can now screw the whole barrel in or out, depending on what you need. And then once I get it at the setting that I want, then I'm going to screw the lock ring back against the lever itself, and that will hold my adjustment fixed in place. Yeah, like I said, any system that uses a cable is going to have some sort of barrel adjuster on it. We have it on our shifters as well. But this is a nice adjustment that can be made even while you're riding. You can just reach down and screw it while you're on the bike. If you're concerned about safety with that, I would recommend stopping and making an adjustment and then moving on. But no tools are required. It's easy to do on the side of the trail if you need to make a quick adjustment. So those are our cable systems. Over here, as I mentioned before, we've got our disc brakes. There's two different types of disc brakes. You can have a cable operated disc brake that uses a very similar cable to these to transfer power from the lever down to the caliper. We also have hydraulic disc brakes, which is what these are on this bike. And a hydraulic brake uses a piston inside of the lever that forces oil down through a hose down to the caliper, where there's two other pistons that that oil pushes out, and it'll squeeze and pinch the rotor and give you your braking power in that way. So differences between the two. Hydraulic systems are very sensitive. It's very easy to feel, to modulate at the lever and feel how much pressure you're applying. They're very smooth. They're also very weather resistant. It's a totally sealed system, so they operate just as well in the rain as they do in the dry. And there's nothing to get contaminated inside of here. If they have to be worked on, that's something you're going to want to take it to the bike shop for. There's special tools that they use to bleed air bubbles out of that system. If there is an air bubble in there, when you compress the lever up here and you force fluid in, that air bubble is going to compress and not transmit that force all the way down to the caliper. So as we know, oil does not compress. So if we have a system that's free of air bubbles, that means that for every bit of oil you push up here, you're going to get a result down at the other end. Other issues that you might have with disc brakes are very similar to rim brakes in that if the pads are worn or contaminated, they're probably going to be making some noise or maybe not working properly. With both of these systems, if you ever hear a metal on metal grinding sound when you pull the lever, that means your pads have worn excessively and there's no material left on them, and you've gotten down to the metal structure that's now either hitting your disc or your rim and causing damage. So you're definitely going to want to get those pads replaced in that situation. One thing about disc brakes that we want to be aware of is that they're very sensitive to contamination. So if you get any type of oil on the disc, then as you're braking, then the pad is going to pick that oil up and it's going to get in the pad material and be very difficult to remove. Then that brake's going to start squealing, or in extreme cases it's going to stop working that well. You're going to have longer stopping distances and less braking power. So we want to avoid touching that disc with our fingers, even just the oils in your skin, or if you have filthy hands like I do right now, you're going to get those things contaminated. So they don't require any special cleaning. They don't require any special care. You just leave them alone. Don't touch them. Another reason not to touch them is that when you're using them, they generate a lot of heat. So if you've come down a big hill, pulled over to the side of the trail, and after a big, long, hard stop, you want to make sure that that doesn't touch the side of your leg or something else, because it will burn you. But fantastic braking systems, and they work really well in all types of weather. And once they're set up, they will work for a long time without any adjustments. So that's definitely an advantage. Another advantage is that if your rim is even just a little bit bent, the braking system is independent from that, so it won't affect the brakes at all. All right. Lastly, I always recommend, especially if the bike's been in storage for a while, even after a visual inspection, that you test your brakes on a safe environment, so like in a parking lot or in your driveway, before you get out onto the road. You don't want to find out that they don't work when you need to make a critical stop and avoid blasting through an intersection or something like that. So always recommend testing them. And once again, if you have any questions about this critical system, or if you're not really sure, we just go to a bike shop. They'll give it a quick visual inspection and tell you, oh, this might be something that you can tackle, or maybe you need to leave it with them and they'll fix it for you. All right, I think that's it for brakes. Okay. We're going to move on now to the C of our ABCs. This is going to be chain and drivetrain related issues, which is mostly what people think about when they think about bike maintenance, because this is a pretty complicated system and it looks like there's a lot going on. We're going to do our best to simplify it for you and to help identify any issues, as well as cover some preventative maintenance that could prevent you from having to have a much more costly repair down the road. So the first thing that we want to do is, before we work on this setup, is that we want to give the chain a little bit of a clean. And depending on how dirty it is, might be more involved process or less involved. We don't want to ever spray anything on our drivetrain. So we're going to want to give the chain a bit of a clean. We don't ever want to spray anything onto the bike, so no solvents, no oils. When we spray stuff on the bike, we may get it where we want it to go, but we definitely will get it where we don't want it to go as well. There's going to be times when we're going to be applying oils that is very near to our rims and brakes. If we get oil on the rim, then it's going to really affect your braking system. And any oil that gets anywhere, or any excessive oil, is going to attract dirt and turn into this really thick black sludge that's going to, give you some problems down the road and just make your bike filthy. So when we clean our bike, this is where having a stand is really nice, but again, if you don't have a stand, working upside down is not all that effective, because the chain is going to be hanging in a way that it's not designed to hang. So what you might have to do is you might have to incorporate a friend or a family member in this to kind of hold the back wheel off the ground for you a little bit while you turn the cranks to identify these issues. A lot of what we're going to be doing, we're going to be backpedaling. So we can do that with the bike on the ground, right side up, and no problems there. So what I'm going to do is I'm going to get a nice clean rag, and the first thing I'm going to do is I'm just going to give the chain a wipe down. The way I do that is I'm going to hold on the chain around the bottom or the rag around the bottom of the chain, like so, and as I backpedal, I'm going to be wiping the top and bottom of the chain and both sides. And then I'm going to be rotating to a clean spot on the rag every so often. And I'm just trying to get any of that loose dirt and oil buildup off of there. We can see that made a difference already, and as you you can see, my rag is filthy. I've gotten some of that off of there. So I'm gonna be cleaning the chain like so. And then as I'm doing that, I'm just sort of visually inspecting the whole system. I'm watching the chain links as they go around the gears, making sure that none of them are stuck or bent. If they are, you'll see an anomaly as in one spot as that's going over like so. So once we get a quick wipe down, we can see what we're dealing with. We want to assess the wear of the chain. So these things have a number of little pivots inside of each link. It basically allows the chain to bend. And where the rivet goes through that inner link, the inside ones here, where the rivet goes through, that hole will wear a little bit, and by a little bit I mean a very little bit, slowly over time. But the wear in each rivet will add up, and so that the overall length of the chain will elongate. You may hear people say that the chain has become stretched. That's a bit of a misnomer. The chain doesn't physically stretch. We just get a little bit of wear at each pivot that will elongate the chain. And when that happens, the holes in the chain no longer match up with the spacing on the teeth on the gears. And if you continue to ride that chain, it may look perfectly fine from the outside, but if you continue to ride that, it will aggressively wear the gears to match the new spacing of the holes on the chain. And those two items become married to each other. And what that means is that you cannot, at that point, put a new chain on these gears, because now the gears are worn to match the old chain and the new chain is going to skip. If we continue to ride with the old chain, it will too eventually skip as well. And at that point, you're going to have to replace all the gears and the chain together at once, and that becomes an expensive repair. And one that can be prevented by periodically replacing your chain when it becomes worn, as well as cleaning and lubing the chain regularly. That's going to extend its life. A chain might be anywhere from 15 or 20 bucks to 80 bucks, depending on what type of bike you have and how high-end you're willing to go. There's usually 3 tiers, so you'll have the low-end tier. The middle tier is going to be in the $35, $40, $50 range, and then the high tier is going to be in the $80 or $90 range. There's not a lot of difference in performance between the middle and the high end, but the high end chain is going to be a little bit stronger, and it's going to be a little bit lighter. So chain is rotating mass, so if you lose any weight in that chain, it's going to give you a big gain in efficiency. I personally tend to go for that middle tier. I find that's the best combination of value and performance. So. The way that we assess the wear of the chain is we have to in some way measure the distance. I want to measure the distance between rivets on these links, and it has to it's supposed to be 1 inch for one inside and one outside link combined. Now you can measure one very carefully, but it's going to be really difficult to assess that wear on just one link because it's so small. So what we do is we measure over a course of several links, and that's going to give us a better idea. And there is a tool like this. There's also a gauge that has a little meter that'll tell you that you can purchase. This one's a little more simple and easier to use. If this kind of mystifies you, you can, again, take it by a bike shop real quick, and they'll just run out, boop, and pop this on there and tell you whether it needs to be replaced or not. But what this does is this measures wear in terms of percentage. So if I look very carefully on the tool, I've got a top side and a bottom side. And the top side right over here says it's 0.5. The bottom side says 0.75. And so what that's measuring is that this is, if my chain fits on the top side, it's going to be 0.5% longer than it was originally. This one is going to be 0.75% longer than it was originally. So if your drivetrain is a 9-speed or greater, and by 9-speed I mean it has 9 gears or more in the back, then you'll want to replace your chain at that 0.5% wear. If it's less than that, if it's a 5, 6, or 7-speed back here, you can get by with a little bit more wear. That drivetrain's a little less sensitive to these sorts of things. So the way that you use this tool is I'm going to take the hook end and just hook it into one link, and then I'm going to see if the other end drops right in. And so right here, notice how that goes in at the 0.5. That means that I'm at least that worn. So if that side drops in, then I'm going to flip the tool over and do the same thing. And if this side goes in, so nope, we're not quite there yet. So we're somewhere between 0.5 and 0.75% worn on this. And this bike being a 8-speed back here, that means we can get a little more life out of this chain, but not that much. So we'll probably be looking at replacing that sometime this season. Replacing the chain is a little bit tricky. There's some special tools involved. So again, bike shop, if you want to learn how to do it yourself, there's a lot of great YouTube videos. You notice we have all these blue handled tools on our wall right here. They're made by a company called Park Tool. There's other tool companies out there, but Park Tool specifically puts out a ton of great YouTube videos that will show how to do each one of these operations individually. So if you want to learn how to do it yourself, you can do it that way. But you want to be able to identify if you're causing wear or damage to your bike or not. So yeah. So our chain is okay for now, but we're going to be thinking about putting it on a replacement schedule this season. Okay, after we determined that our chain is okay to still use, and we're going to move on to the next parts of the system. So we're going to be looking at our derailleurs, which is the mechanism here that moves the chain from gear to gear. We've got one in the front and one in the back on this bike. You may only have one in the back. Depends on the bike and the type of drivetrain that you've got. But we're going to want to quickly look at these inspect them for visual damage. The derailleur itself is kind of vulnerable where it is on the bike. It's attached right up here, but if I grab and wiggle down here, it can very easily move around a little bit. And if you're to crash or lay the bike down or transport it in a rough way, it could become hit and bent. And what bends is usually this part right here that the derailleur is attached to. So this is called the derailleur hanger. It's a sacrificial piece that is designed to either, if this gets bent or broken, it's very easy to replace, and you don't have to replace the whole frame that it's attached to. So what I'm going to do is I'm going to sight down the back of the bike. I make sure that I'm looking straight down the frame, and I'm looking to see if the cage of the derailleur lines up with the plane of the gears here. And so if this is bent in or bent out, and the cage is this part right here, if it's bent in or bent out, or if it's twisted in some weird way, that means that this piece has become damaged. If you suspect that's the case, you're going to want to take it down to your bike shop. They have a tool that they can put on there that will tell you for sure if it's bent. This piece is different for different bike frame manufacturers, so you can't just get a generic one. You want to go to the bike shop that sells the bike that you have, and they will be able to get that piece for you. If that is bent, you can try to bend it back, but I really don't recommend that because they're usually made out of aluminum, as is the frame in a lot of cases, and they don't like aluminum does not like being bent twice. So once it gets bent, it gets brittle, and you try and bend it back, it becomes weak, and it can easily break in that situation. So again, it's designed to break and replace easily. They don't cost very much money, and so yeah. If it is bent, one of the dangers of riding that bike is that the cage of the derailleur could become entangled in the spokes. And if that happens, it's going to very quickly break off and become all mangled, and likely you're going to have to replace the derailleur. You may break some spokes, you might damage the wheel. It causes a lot of problems, so you want to make sure that that's working properly. The other thing that we can do is we can kind of assess how worn out the derailleur is by grabbing the cage and wiggling it back and forth. It's normal to have a little bit of play like this, but if you're getting excessive play, or if you notice that where the derailleur is bolted in, maybe that's wiggled out a little bit, you'll have excessive play in that situation. You'll want to see if that's happening there, and you can just tighten this bolt, or if it's happening just in a sort of accumulation of all the wear in the various little pivots in the derailleur, then this is probably going to need to be replaced sometime soon. Cool. So we've assessed the wear. We've cleaned the chain a little bit. Next thing we might want to do is we might want to give the gears a bit of a brush. Now I have a specific brush for this. This does not need to be a bike specific brush that you use to knock the dirt and oil off of your gears, but you want to make sure that the brush that you do use for this, that you're not using for other things, because it's going to be contaminated with all kinds of dirt and oil. And if you use the same brush here as you do on the rim, you're going to be cross-contaminating things. So I have a specific brush that I use for this purpose. And I'm just going to, while I'm holding the pedals here, I'm going to be just brushing down like so, letting all that stuff just fall to the ground. And you're going to go all the way around. These particular brushes have this other side that you can use to remove debris from in between the gears like so, and that's kind of nice. Not necessary. If you don't have that, you can take a rag and you can slot it in between. And this rag's a little worn out, but yeah, like so. And you can, let me make sure you can see that. You can slot it in between those gears and you can kind of floss it a little bit, rotate it, floss it a little bit, and then go down between each one. You don't have to do this that often, especially if you're riding on the road. Once or twice a season is probably fine. It depends on how much you ride your bike and in what conditions. But we're going to knock all the loose dirt and debris off of there. If there's a tiny little bit of rust on some of these components, that's fine. When you re-lube the bike, the oil that you use is going to cure that rust over time. You just want to make sure that you're not allowing it to rust if you can help it. So where you store the bike is kind of critical there. If it's stored outside, you'll really want to make sure it's well lubed all the time. You can get away with a little bit of dryer chain and gears if it's stored indoors and not ridden in the wet that much. But yeah, so once I've cleaned those gears, I'm going to do the same with the ones in the front. This chain has a guard on it so that you don't catch your pant leg in the gear teeth. But again, I'm just kind of going to go through. I would maybe stand over here for this. And I'm going to try and get my brush in on all those teeth going around. And then you'll want to make sure that you shift the chain into some different gears and then brush the gear that the chain was sitting on. So I'll go through and I'll scrub them all, and then I'll shift both sides into some different gear, and then I'll very quickly hit those two spots that I missed before. Once you get to that point, now it's going to be time to assess the shifter and the shifter cable. So we have different ways of shifting our bikes. The cable operates very much like the brake cable does, in which you pull a steel cable against the housing that it's in. That housing has reinforcement so it doesn't compress. That way every inch of cable that I pull up here by the shifter is translated to movement back here at the derailleur. Again, very sensitive to damage of the cable and housing. So when we shift in one direction, we're compressing or expanding a spring inside the derailleur. We shift back in the other direction, that spring is going to be taking up the cable slack. And so if there's excessive drag inside the housing by a rusty cable or contaminated cable, that spring is not going to be able to pull that cable back through, and you're going to have poor shifting or slow shifting on the bike. And so this bike has twist shifters on here. You might have little clickers where there's one thumb lever that's kind of hard, and that is taking cable up when you're pushing that lever, and then a trigger that meters a little bit of cable back out going the other direction. You might also have shifters on the bike down here or on the ends of your bar that are kind of, you can move them infinitely in each direction. That's an older system. Those systems you almost tune with each shift while you're riding, so they're very easy to set up to begin with, but more difficult to use while you're riding. This bike has what we call, and most bikes these days have what we call an indexed shifting system. So what that means is that there's distinct clicks. Get one there. There we go, there's one, and there's two. There's distinct clicks on the shifter that pull a measured amount of cable with each click. And when that cable is pulled, that moves the derailleur a very measured amount that goes from one gear directly into the next. So if there is damage in your cable housing, some of that cable that's pulled through is going to be taken up by that cable housing compressing or like shifting because it's kind of broken in one spot. And so your derailleur won't hit each gear properly as you're metering out those clicks. If we imagine each click on the shifter being one of my dirty fingers over here, and each gear being on this end, our overall cable tension is going to adjust where those clicks line up with the gears. So if we add tension, all of a sudden now none of our clicks are in the right place. So every time we shift, it's going to be off. If we continue to add tension, we could get them to line up here, in which case these middle gears will sort of seem like they're working, but you'll get to either end and these won't line up. And so again, there's a system for metering or for adjusting the overall cable tension, which is going to be doing this sort of thing, using this metaphor. And that's using a barrel adjuster at the shifter. Again, this is just a twist, so if I screw it in towards the derailleur or towards the shifter, it's going to relieve tension from the system. If I unscrew, it's going to add tension to the system. So the idea is that if you can get the bottom or top gear to line up, usually you go with the smallest gear if we're talking on the back. If we get that click to line up, then every other click up the chain should work properly. And so we would do the cable tension adjustment for that. There's some other adjustments that you have on your derailleur back here. There's a couple of screws that you can see right here and here. Those are our limit adjusters. So what these screws do is one will adjust how far out the derailleur is allowed to come, and the other one will adjust how far in the derailleur is allowed to come. So if we were to put a screwdriver on those and screw them both in all the way, that would limit the derailleur right in the middle of the gear range, and it wouldn't be allowed to move in either direction. So if the chain is not coming all the way down into the smallest gear here, or not going all the way up into the biggest gear, we want to try and figure out, is that a cable tension problem, or is that a range of motion with the derailleur problem? So, and then when we adjust those, if we do, we want to make sure that we're turning the right one for where we're positioned with the chain. If we think about the big picture here, if this worked properly before and you put it away and now all of a sudden it's not shifting properly, it's very unlikely that these came out of adjustment. So I would caution against changing any of that if you don't know what you're doing. It's very easy to get it way out of whack than it is to get it tuned properly. If there was a sudden change in the way that your bike's performing, it's much more likely that the cable became damaged in some way or the derailleur hanger got bent. It's less likely that these sort of just came out of adjustment. If somebody was monkeying with them and they got turned out of adjustment, then they're going to need to be put back in by somebody that knows what they're doing, or you're going to have to do a little bit of homework to determine how to do that properly. But again, sometimes people will transport their bike, they'll mess up something with the cable, or they'll crash and mess up something with the cable or the derailleur hanger, and the bike won't be shifting right, and they'll think, oh, okay, I just need to tune it by turning these screws. I would recommend against that. The front derailleur has the same thing right here. And that's again a limit adjustment. It's going to allow how far in or how far out it's allowed to come. Coming it back to our rear derailleur, if we were to say unscrew the upper limit, we may now allow the chain to the derailleur to shift too far in, and again it can catch up in the spokes in that situation and cause a lot of damage really quickly. So if you are turning those, I would do it with caution and do a little bit of extra homework on how to do that. Yeah, so with the bike up on the stand here, I'm just going to very quickly shift through all the gears and make sure that they can go one at a time and the bike's not making any weird noises. And go all the way up, and then we're going to go back down one at a time, making sure that it can very cleanly hit each mark. And that's working great. Notice I use the brake to stop the wheel, not grab it myself because that can hurt you. Okay, so we've determined that our derailleur is good. We visually inspected the cable to make sure it's good. One of the things that I forgot to mention before, that your cable system, where you can have problems, is if the cable housing is allowed to come out of its stop. And so I'll just sort of briefly demonstrate what that looks like. If I shift this up and then do that. So I've relieved some tension in the cable right now, and I can pull it up and then it'll come out of the stop. If that's come out of the stop, then now this system's not going to work at all. If I shift, it's going to go all the way down to the smallest gear, and now when I do the shifter, nothing happens because I'm no longer pulling the cable against the housing. The housing is just floating free. So the housing needs to be in those stops fully and properly. So again, this is an issue that comes up a lot when the bikes are transported on bike racks or in and out of cars, and they're kind of snagging up with each other, and somebody pulls a little hard and then maybe the cable popped out of there. So in order to get it back into the stop, you're going to want to relieve as much tension as you can. And what I might have to do is kind of push that in there, and then it'll slide in. There's a slot on the bottom side of the stop that allows the cable to slide in there, but the housing is held firmly. And there's a few of those along the system. There's one right here, there's one right here, there's one right here, and there's one up at the shifter. And so you'll want to visually inspect those and make sure that they're all in there properly, and that the cable housing is not damaged in any way right here. There's a little cap on the housing, and you want to make sure that's on there as well. That's a critical little piece. So that keeps the housing all together at the end and make sure this whole system works properly. So shifting looks good. One thing to note with front derailleurs like this, these drivetrains are not designed to run in extreme combinations very well. So if I'm all the way in at the smallest gear on this side and I'm all the way out on the smallest gear on this side, the chain has to make quite an aggressive angle to make it in from this one all the way out to that one. And if we note also, there's quite a lot of slack in the chain because I'm in the two smallest gears. I can replicate this same gear ratio by shifting into the middle gear up in the front and some of the middle gears in the back. That's likely going to feel exactly the same on the bike, but I've now brought the chain in line and it's going in a nice straighter line. If you do have it set up in those extreme gears, so all the way in the smallest one here and all the way in the smallest in the back, what you might find is that the chain's going to make a little bit of a rubbing noise on the front derailleur. It can only swing so far inside of this cage. And if it's coming off at a skew, it might rub up against the derailleur. You might think that the system's out of adjustment. That's not out of adjustment, that's just how it's designed to run. So maybe think about, is there another gear combo that I can get the same ratio with that's going to give me a straighter chain line? Okay. So last thing I'm going to do is I'm going to shift back down into that smallest gear. It's time to apply some lube to our chain and our drivetrain system. So there's a number of different styles of lube that you can get. You can go to a hardware store and get sort of like a 3-in-1 oil, which is like this stuff right here. This is a multi-purpose light oil. This will work, but it's not specifically designed for what you're doing. So I recommend getting an actual bike chain lube. There's several different brands out there. One thing about chain oil that you get at a bike shop is you can choose the formula that best suits the type of riding and the conditions that you're riding in. So it's rated from wet to dry, and what that means is that a wet lube is going to be designed to use in wet conditions, more a dry lube for dry conditions. So the wet lube is going to be a stickier, more viscous stuff. It stays on the bike better. So if we use a dry lube in a wet condition, riding out in the rain and stuff with the dry lube, not as sticky, not as tenacious, you may lose all of your lubrication just in one ride, and your bike's going to be squeaky and not shifting properly and causing excessive wear to your chain just within that one ride. If you use wet lube in a dry environment, that oil is really sticky. Dust and debris is going to stick to it, and it's going to turn into that thick sludge that's going to affect your shifting and be really hard to clean off. So we want to choose the appropriate lube for our conditions. Here in Coeur d'Alene or in North Idaho, we use dry lube most of the time, because most of the time that we're out riding, it's nice weather here, we have very dry conditions, dusty trails. This is going to work really well. If you're diehard and you like to ride in the rain, or if you commute and you're day in, day out, you might want to try a wetter lube. You're just going to have to do some experimenting and find out which works best for you. So when we do lubricate the chain, what we're trying to do is we're trying to apply 1 drop approximately of this lube to each one of the rollers in the chain. And the rollers are the little washer that's right in the middle between the two plates of the chain. We're not trying to get lube on the gears. We're not trying to lube anything else. We want lube on the inside of the chain, not on the outside of the chain. So one could go along and very carefully drop 1 drop of lube on each link, and if you're a meticulous person, that's the very best way to do it. But it's a little impractical. So what I'm going to do is I'm going to stand over here. I'm going to position the bike vertically. That's important, because if we miss or if we drop excessive lube on there, we want it to fall and hit the ground. We don't want it to hit the tire or the rim where the brakes can catch it. If that does happen, you want to make sure to clean that off before you apply the brake, because we don't want that lube to get into the pad. What I'm going to do next is I'm going to brace my finger against the frame somewhere, like right here, and so that I can control where I'm going. And I'm going to start slowly backpedaling, and as I do that, I'm going to bring the lube down, so I'm just dripping it right onto the top of the chain. And I'm going to keep going all the way around until I make sure that I've got oil on each link. Again, we're shooting for about 1 drop of oil on each roller. And next I'm going to just cycle that a little bit. Let that oil work its way down into the chain. And the next thing I'm going to do is I'm going to get my rag again. Make sure I get a nice clean spot on the rag, or a fresh rag if I need to. And I'm going to do that same function where I'm holding the rag on the chain. While you're doing this, you want to make sure not to pull it in or out. You might actually shift it on the gear while you're doing that. So we're just staying right where the chain wants to be, and we're cleaning the top and bottom and the sides. The idea is that we are cleaning the lube off the outside of the chain, leaving just a little bit of oil on the inside of each one of those links. And if I'm observant, I would notice that the chain is quieted down a little bit. If it was squeaky to begin with, it'll quiet down a lot when you do this. So that's a good indication that you've lubricated it properly. If your chain was really, really dirty, there's some ways that you can clean it a little more aggressively than we did before. You can apply some solvent, like some WD-40 or something like that, to a rag. Never spray it directly on the bike. Apply it to a rag, and then use that the way we were before. If it's really, really dirty, you can remove the chain from the bike in some cases and clean it with some solvent off the bike, and that'll do the job. If you do this service regularly, that oil will help flush dirt and debris out of that chain periodically over time. So it's a good idea to do this at regular intervals, even if the chain looks like it's got a little bit of oil on it. If you look at it and say, oh, it looks like it's got some oil, but it's been a month since I did this, maybe a little fresh service will help just flush that dirt out and keep it clean over time. Let's see. Oh yes, a lot of people will try to use WD-40 as a lubricant, because if you have a dry, rusty chain and you spray some or apply some WD-40 to it, it's gonna quiet right down. It's gonna sound and feel like it's well lubricated at first. WD-40 is a mix of mostly solvent and a little bit of oil. So if you use it to clean apart, that solvent will then evaporate, leaving behind just a very fine film of oil that's only designed as like a light corrosion protectant. So if you're trying to put something on the shelf for a while, it'll keep it from rusting for a little while, but it's not enough to act as a actual lubricant. So it's not going to do the job that the chain oil needs to do to keep that chain working properly without wearing out prematurely. Yeah. Other than that, any other shifting issues? Again, I would recommend you take the bike down to the bike shop, and they might be able to address those concerns. This is one of those things that there's a lot of different little adjustments and a lot of tricks, and it's very easy to get it out of adjustment. It takes a little bit of know-how to get it back into adjustment. So if you're doing this regularly, these cleaning and lubing and maintaining operations will help you identify any issues early. And if you get them fixed early, they become less of a big problem. So, fantastic. That concludes our ABCs. I'm just going to cover a few other checks that you should probably do periodically, or at least once a season, to your bike, or even once a ride. You want to pay attention to, you want to periodically pay attention to the noises that your bike makes in normal operation. If it all of a sudden starts making a noise that you're unfamiliar with, it's a good idea to stop and try and identify where that noise is coming from. One of the best ways to do that is to stop and take the bike and just gently drop it, like so, and listen for any clunks. If something's out of adjustment, like if our bearings that our fork rides in here, or our bearings that our crank rides in, or our wheel bearings, if any of those have issues, they'll usually be identified as a clunk when I do this. And so if I hear a clunk, then I'm going to try and narrow it down. Is it on the front of the bike, or is it on the back of the bike? One thing you can do is grab the front brake and kind of gently rock the bike back and forth. If you feel a clunk, 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 clunk as you're doing that, it's usually these bearings in here. You can grab the wheel like so and try and wiggle it back and forth this way. If you feel the wheel wobbling in there, you want to check and make sure that it's installed properly. If that seems like it's installed properly but it's still doing that, then the wheel bearings themselves need an adjustment. If you might grab the seat and wiggle it around a little bit. Sometimes the bolts that attach the seat to the bike can back out or become bent or worn, and the seat will wobble around a little bit. The cranks, if you grab the cranks and kind of wiggle them like this, basically you're trying to wiggle things in directions that they're not supposed to move. And if they do move, then you gotta adjust that, or take it to a shop and have them take a look at it, make sure that it's safe. As with anything, with most things, if there is some play happening in those bearings, and you let it go too long, it's going to cause a lot more damage and be much more costly to fix than if you can catch it early, and it might just be a quick adjustment and you're back on the road. Other than that, I will say that we're blessed in this area with a lot of different shops and all around the town. So we've got them up in Hayden, down in Coeur d'Alene, out in Post Falls. Spokane has a number of great shops. All of them are very reputable, very friendly. If you purchase your bike through them, it comes with a bit of service usually. If you have a brand new bike, it's pretty common that after you've ridden it for a few miles, that there's going to be a few things that need to be tightened or adjusted. If you buy your bike through a bike shop, they usually include that service with the sale. Even if you didn't, I would recommend getting a good rapport with one of them and bringing the bike in regularly for a more involved check. If you do that, you're going to get a lot more life out of the bike. And again, if you're able to identify these issues that we've discussed in this video, then you'll know when to take it in and save yourself from some more costly repairs down the road. Awesome.